in the field of algorithmic bias, it is all about the data, but what part of the data contributes to the bias depends on how the data is flawed.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Here with me today on How AI Happens is founding engineer over at Arize AI, Tsion Behailu. Tsion, welcome to the podcast. How the heck are you today?
I'm good. Thank you for having me.
So pleased you're here. You are sprinting on your way to a holiday in London. So thank you for squeezing me in. I know how things get hectic right before the break. I appreciate you taking the time.
Yep, no problem.
So much to go into with you. First, I think maybe it would make sense to just get to know you a little bit. Would you mind sharing a little bit about your background and how you wound up in your current role at Arize AI?
Sure, yes, I'd love to. My name's Tsion Behailu. I'm a part of the founding team at Arize AI, and I'm a staff software engineer on the full stack team. I grew up in the Metro Atlanta area, and I left for college. I went to UC Berkeley. That's where I sort of discovered computer science, tech, all the great Silicon Valley things, and decided to pursue that as my interest. So after studying CS, graduated, did the usual big tech life, joined the Google at Sunnyvale, Mountain View area. And I was there for about 2.5 years, had a really great time, but I just wanted to change. So I transferred to the New York office, worked out of the Google office there for about a couple of years. And that's sort of when this opportunity sort of came up to explore startups. And I had a friend at the time from college. She just co-founded an ML company and, reached out to me. And it was a really great time in my life. And I decided to just take a chance on it. So I started March 2020, cusp of the pandemic, about March 8th, right before New York shut down. So I pretty much spent the entire pandemic helping build a product from the ground up and still here. So having a great time.
Good. Glad to hear it. And what was your experience with machine learning before coming to Arize?
I had almost no machine learning experience. Aside from an upper division AI course in college, I hadn't worked on anything really ML related at Google. So I actually appreciated the opportunity to be able to learn ML from scratch pretty much in a startup environment. Also learn how to build a product from the very beginning. Like at Google, you're working in a really big system. So it was a lot of late nights on the call. The co-founder of Parna, she was graciously spent many hours on Zoom with me, teaching me every single ML term, and while I'm actually writing the metrics for the platform. So definitely a crash course, ML 101 and 102, all the courses on the job.
Yeah, so it was kind of on the job, just in time learning for you.
Yes.
So I speak to folks on this show who they'll tell me, I've been in AI since the late 80s. And Rob, I bet you didn't even know AI existed in the late 80s. But you're a little newer to the field. So I'm curious, what has struck you when you got into ML and started upskilling and learning about this field? What sort of stood out to you about this as compared to your previous background in CS and engineering?
Yeah, so I spent about 4.5 years in industry prior to joining Arize. And I think what was really refreshing was just getting back to the theory. In college, we focused a lot on the theory side of computer science. And I did enjoy the application side, actually building things, implementing, making things work. Ultimately, as an engineer, you get a lot of gratification from making things work. But getting back to reading up on why a metric is important or how it's implemented, or really just digging into the entire ML field, model building, model analysis. It was nice to just have my brain exercised in a different way. So I think that was probably the most notable part of it for me, switching from industry into something a little bit more research backed.
Got it. So you were able to kind of combine this theoretical with now this practical of building and shipping products.
Yes.
So at that point, you've got a few years in the industry under your belt. Google is a gold star on your resume. You probably could have picked a few different options. Why machine learning?
I was really curious what the hype is. I feel like that's why I joined Google to begin with. People talk about it, and I was like, well, let me go see what it's all about. So I did go see what it was all about. It was really great, a lot of perks. But then I got, as my sort of like curiosity around how next do I want to propel my career? Is it exploring different teams inside the company? Is it going to a startup in a more emerging field? So I felt like that's the allure, getting to be part of something breaking edge, but I also cared about the environment in which I learned. So I was pretty hesitant about just going to any startup. You hear all the horror stories. So just having someone I was very close to, really respected and knew would make sure I was in a healthy environment while I'm learning something new in my field. All of that combined was sort of what tipped me over into going for it.
Yeah, that makes sense. Trust is so important, especially with these smaller companies at the beginning. So you wanted to see what all the fuss was about. What was all the fuss about? How would you kind of characterize Arize AI's mission?
Arize AI, where do I begin? So yes, we're a platform to help monitor and troubleshoot AI models. So what that means is model building has really been taking off. It's hot button topics. We've got all of the tools right now to build models, but you build a model, you put it into production, what happens then? So we focused on machine learning observability. So we're helping ML teams detect issues, troubleshoot why they happen, and just improve overall model performance. And that part of the life cycle was at the time very much new. So we're kind of helping shape what that means in that space. That was really exciting. It's like kind of being part of the early stage of the market. Aside from that, you're building tools. We've really shaped up. There was no website when I joined. Now we have a really fully fleshed product. I encourage you to check it out. I'm very excited about it. And also developing it in a pandemic, you get to output a lot more work than if I was like dilly-dallying in a Google cafe.
Of course, yeah. Would you mind sharing a little bit about what is meant by ML observability?
So ML observability is kind of what it says. It's you're observing how your models are performing. Let's say you have a model that's sort of degrading in accuracy over time, right? So maybe you launched it in a new state. Like you have a model that's like predicting something time related or really anything, but you've launched it in California. Now you launched it in Arizona, and all of a sudden it's like degrading in accuracy. How do you know it degraded? Well, if you were using Arize, you would be able to quickly monitor the accuracy of your model over time, get an alert that it degraded in accuracy from 90% to 70%. So that's just one of the many examples. There's obviously many ways in which a model you can measure the performance. There's like precision, just the prediction would be like drift, like are your features drifting? So in the machine learning research space, there's so many metrics that researchers are coming out with, and we're quickly adding them to the platform. We're also adding the ability to allow customers to do custom metrics. Maybe they have things that they care more about that we don't have available. But yeah, that's what we mean by observing your models.
Got it. So what is of most common concern to Arize's customers? Is it pure accuracy, drift, precision? Those are the examples you mentioned, but what do you see coming up the most when people are asking for various things to observe?
If you're thinking of the categorization of metrics, you have performance, data quality, and drift. So it depends really on the customer and the type of models that they're building. If they're building maybe models that are just predictions, maybe they only care about drift. If they have models with ground truths and they're trying to analyze the performance of it, they might want to use one of our many like performance metrics. That's accuracy, precision, F1 recall, all of those. And if they just want to care about the data of the model, like let's say the cardinality is changing. The cardinality of this feature was only, they want to have a certain set of unique features. And now all of a sudden a new feature showed up. Maybe they care about that. So it's depending on the industry that the customer is in, the type of models that they're building, they might care more about a drift, a performance, or a data quality metric.
Got it. Now, this maybe gets into the founding story a little bit, but what is your understanding of how ML professionals were monitoring these sort of things absent a tool like Arize?
The troubleshooting process prior to the sort of ML observability space is pretty manual. And it kind of is probably pretty manual in a lot of companies to this day. So let's say a problem comes up. Now the data scientist or the ML engineer has to go and say, oh, well, why? Why did this model all of a sudden stop working, or like this degraded so badly in production? They pull that data, they try to comb through it, hone in on where the issue is, fix it, and then deploy. But because of this, there's, of course, like a lot of business implications. You're losing money. You're losing trust in whoever your customers are. So what our customers are doing right now is either they're looking for companies to provide the service, or they're trying to build their in-house solution. But in-house solutions take a really long time. They're not easy. And they still probably have a very manual step as well. And they're probably also very much developed specifically for a certain subset of models that customer might be building.
Right. And even assume there is like a reliable internal process for checking up on that, there's still the question of how often do you check up on it, right? How, like, is it constant? Is it once a day? Is it once a week? That's time your developers are spending away from other things. Instead of building the models, they're tweaking models or making sure the model does what it's supposed to do. Feels like maybe a poor use of time that adds up over the long run. So I'm just curious about that, because every exciting usable product has some really awful pain point at its base where people are like, oh yeah, it would be really amazing if I didn't have to XYZ. And in this case, it's, maybe it's like a spreadsheet or however you're tracking this manually, as you said, that wouldn't it be better if you just got a notification?
Exactly. Just to add on to that, let's say the in-house solution is like a dashboard, right? It takes a lot of engineering effort to build integrations. Like maybe you want to be notified on Slack. Maybe you want to be notified by email, or like PagerDuty. Like building also like that huge set of integrations is also a lot of work. So if you have an in-house solution, it might just be a dashboard that someone still has to manually check every day, and it might not go as granular into the model. Like how do you break it down by feature, like filtering? So yeah, just a little add-on to what it could mean to like have a very robust in-house observability platform.
Yeah, that makes sense. So you mentioned some of the things it can drill in on are drift accuracy, precision over time, etc. What about bias?
Bias is really exciting because earlier this year, we released a product that lets you explore bias in your models. And this was really interesting for me because it's the intersection of actual like real world issues with ML. So I had a really great time leading this project. So models can be biased just because they're built on biased data. Even data scientists, ML engineers who build these models have really no standardized ways of like to know if they're perpetuating bias. And so more and more of our decisions get automated and we let software make them. So we really do allow software to perpetuate real world bias issues. So what does bias mean? In different industries and different model use cases, it can really mean different things. So healthcare field, it's as healthcare being provided equally amongst its population. In finance, is there a bias against, who's getting approved for loans? You also have a lot of facial recognition software out there right now. And how's that data being used? Is it eventually becoming discriminatory? And I think my most popular, and probably the ones that we see the most in online and in news articles, just because they're very buzzwords, is like social media. How are these social media algorithms building their timelines, like the trends? Is it hurting different content creators? So there's just so many real world implications when it comes to very much like throwing models out into production and having people interact with them with no safeguards.
Enter the bias tracing tool, right? And into all of those examples of problems. How does it detect bias?
The bias tracing tool that we have is to help data scientists and machine learning teams just monitor and take action on model fairness metrics. So what we mean by model fairness metrics, we decided to focus on 3: recall parity, false positive parity, and disparate impact. And these are all measure things like how sensitive the model is, like compared to one group or another. Like, is it predicting an outcome more likely for a marginalized group over a base group? Or is it falsely predicting something as more likely for a sensitive group? And these sensitive and base groups could be gender, race, age, religion, nationality, really any protected attribute. So this was the first set of metrics we decided to release, and it's been pretty heavily used. And you can compare it against like either your model's features or like additional metadata that you might have ingested with your model.
I'm really interested in the whiteboard session from which those three buckets sprang when you came up with, okay, we are going to focus on recall parity, false positive parity, and disparate impact. Could you share a little about that conversation and how the team over there decided this is how we're going to kind of put a circle around what it means for a model to be biased or what goes into a model being biased?
Yeah, so the discussion around the metrics that we're supporting is really around the research that's happening in the algorithmic bias space. So if we're seeing that, hey, a lot of models are discriminating against marginalized groups because they end up being more sensitive for those marginalized groups, like we want to make sure we're including recall parity. And it's also based on the customers, right? So if the customers are primarily in a certain industry, and this is the way that the discrimination is happening, or the bias could show itself, then let's integrate those type of metrics. So this is sort of like the conversations we're having around like the metrics to deliver. Obviously, as more research happens, we want to be able to flesh out the feature even more and add more offerings to the platform.
What does the output look like? Say I run the tracing tool on my model and, the alarms go off and then like, Rob, your model is mad biased. What does that actually look like?
Well, first you can go to the platform, use it. We've got some demo models for you to play around with. But the way the measurements work is, you probably have a range that's safer. Like if your model is at 1 or at 0, like it's either good or bad. So if you're noticing like the trend over time is, on the middle of the month, I see a huge drop in recall parity. Well, what did I ingest, or how did my model's data change? So you actually have like a feature breakdown. You can go and examine the feature, click on your data set, see what's the composition, and see the distribution of the feature. So it really helps. And maybe like it happened during training, like you ingested new training data, or it happened in the validation step. So we support those environments as well. So you get to really dig into the model, examine the data set at the feature level. And then maybe if you filter down on that feature, does the metric improve? So you can kind of see, this feature is really the one that's sort of causing the degradation in my metric.
Interesting. Okay, so it does show you timing, which feels really important because knowing that you're biased or that your model has biases is like less than half the battle, because you have to understand where that comes from. Even if I know I'm biased, you still have this blind spot because it's like I don't have the life experience to understand where I'm even being biased, right? So is that meant to be prescriptive, where it shows you here's where this bias began to show up, and now you need to drill in and ask yourself what changed at this moment to result in it? It's like, what is the second half of this once it's detecting the bias? Is it prescriptive to be like, and here's why?
Yeah. So when I think of the model lifecycle that ML engineer might be going through and that we would be a part of, it's their model building, right? They first build the model, they train it, validate it, and then they release it into production. And then we fit into the observability part. So we observe the model for them, alert it, they get that notification, they get to drill down, figure out the root of the issue, start back at building the model now with that fix. And it sort of is like now a healthy ecosystem of model building and model monitoring. So I don't want to say that's what you're supposed to stick to, but that seems like, to me, like the type of ecosystem you should have. It should not just end at, all right, model's out there, let it do its thing, hope it doesn't break, hope it doesn't cause any issues. But it's sort of a circular ecosystem of building, observability, and then iterating on that.
In your opinion, Tsion, what is most responsible for bias showing up in ML models? Is it merely data? Is it the data annotation? Is it the professionals themselves are imperfect? Where does this come from?
That's a really good question. So the common causes of bias in ML systems could be a number of things. It could be a limited amount of features, like maybe some features are just less informative or reliably collected for minority groups. It could be skewed sample. So where are you getting your data from? It could be tainted examples. So if you're thinking around job orgs, like maybe if the system uses hiring decisions made by a manager, as labels to like select applicants rather than the capability of a job applicants, then the system is trained using these samples will like replicate any bias from that manager's decisions. Or it could just be like sample size disparity. Like if the training data coming from the minority group is much less than those coming from the majority group, is it less likely to model perfectly the minority group? So yeah, in the field of like algorithmic bias, it is all about the data, but it's like what part of the data contributes to the bias depends on how the data is flawed.
There's really no limit to the way that bias might creep in, is what it sounds like. I hesitate to try and simplify this much, but it does feel like if data was collected in a bias-free manner, that would solve a lot of the problem. However, in the cases where you're relying on historical data, it's either skewed in its collection or in its being recorded, all these problems. This is maybe a tough question, but what can one do in the case of bad historical data? Do you just throw it out? Like, do you get to a point where you're like, we can't use this because it's inherently biased and we can't change it because that would be changing how it was recorded? Like, do you see what I'm getting at here? Like, what does one do in a case of historically bad data? You still want to presumably make a model.
Yeah, no, that makes sense. I think of also around just the lack of regulation in sometimes tech spaces. So when you think of a model's bias, like who's going to still stop you from using the model? And right now it's just at the very early stages of having government level regulation around your models. And I feel like maybe if you start at the end, like you have a base set of metrics that machine learning experts say this is a starting point for evaluating your model. And if it performs at a certain level, then you have to go back and look into your data and figure out how to fix it. But that's not even there yet, right? Like what's the motivation for businesses to go and fix their data? And what measurement are we using? What are the regulations around where you have to sort of perform? In so many older industries, there's just like a bar that you have to be at. And I don't know if we're there yet as a society.
Yeah, there's just really no consequences for not doing this, right? For not honing in on how you're biased. And even in a world where everyone's using the bias tracing tool and it's fantastically successful and widespread, there's still going to be people who don't bother to optimize for that, right? You're like, oh no, that's just an added expense and who cares? We'll just ship our biased product, right? Because people will buy it. That's just another one of these perverse incentives, I suppose. And so until there are consequences, unfortunately, we expect this to continue.
No, make it a business incentive, I always say. So I don't think it should be a good faith thing. It's great if a company decides to incorporate this out of just going above and beyond. But if it's a business incentive, then everyone sort of has to abide by it.
What would it look like if it were a business incentive?
I think it would just be like having the people, first of all, that write these bills sort of be working side by side with the experts in the field, figure out what is like a mandate for the things that impact a certain like population. I honestly think even just like, the fields like the healthcare field, the finance field, even social media, it'd be nice if there was no discrimination there. So yeah, just if the way that we're crafting the bills takes into account what is the sort of standard, and then having that be like you're penalized if you don't follow those standards.
Yeah, that makes sense. It's a start anyway. So before I let you go, Tsion, I wanted to ask you, for the folks out there who are working on their ML models, maybe they are just beginning on their bias tracking journey. They suspect their model is biased, or they're sure it is because they know that they're a flawed human being with with their own biases, but they don't know where to start. How can someone just begin to monitor the potential bias that their technology may suffer from?
Yeah, no, great question. You can use Arize. Start by ingesting your model. We're out there, and start collecting the metadata for your model and just see how you evaluate on just some of these fairness metrics. It's a really great starting point and insight into figuring out a starting point for your model.
Presumably this person is a data scientist or something adjacent, so that they know their way around data. Point that expertise at the potential bias and you will make progress at the very least. Tsion, this has been a fantastic conversation, and we are creeping up on optimal podcast length there. So at this juncture, I would just say thank you so much for being here and sharing with me your experience and expertise. I've loved chatting with you today.
Ditto. Thank you so much for having me. I really enjoyed being here.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.